Hi all, it's Mr. Lim here again, and this is our video on polyprotic acids in the acids and base series. So let's get started. Right, so this is what we're going to be learning about. Okay, and let's have a look. So, acids we know produce hydrogen ions in solution under Arrhenius' theory. Okay, and that's what we're doing in year 11. So, some of these acids can produce only one hydrogen per acid molecule. Okay, so the idea is that there's many acid molecules and then they produce one hydrogen for every one of those acid molecules. These acids are called monoprotic acids. Mono being one, protic meaning protons. Okay, so these acids can only produce one hydrogen ion per acid molecule. Some other acids can produce two hydrogen ions per acid molecule. Okay, so because they can produce two, they're called diprotic. Di being for two, protic for protons again. All right, and then some of them are even more fancy. 3 hydrogen ions per acid molecules. No prizes for the guesses. They're called triprotic. All right, so effectively, you need to know which acids produce 1, 2, or 3 hydrogens per molecule. Okay, and these acids that can produce more than one, if you can produce more than one, right, these are called polyprotic because poly just means many. Okay, so you call polyprotics is the di, the tri, and even the higher values going on. All right, so let's move on. These are the ones you should know about. So monoprotic, HCl, nitric acid, HNO3, hydrofluoric acid, HF. And I want to just spend some time with ethanoic acid. So just be aware that ethanoic acid has 4 hydrogens there, right? But only one of them can act as a, fall off and turn into a hydrogen ion. Okay, and it's this one here, that's the one that falls off. So when that does fall off, it becomes, oops, that's not what I want. It becomes CH3COO minus as the ethanoate ion. So these hydrogens here do not make this a polyprotic acid. It makes it just, it's still a monoprotic acid because only one of them can fall off. Okay, so those hydrogens do not count. Okay, so then we have the diprotics, your sulfuric acid, H2SO4, your sulfurous acid, H2SO3, and you have oxalic acid, which is sometimes shown as C2, H2O4, or C, no, not C, HOOCCOOH. Okay, and in this case here, both of these hydrogens can fall off. All right, and then you would call oxalate the substance that is formed, and you would do, oops, that's not what I wanted again. Right, OOCOO, and 2 minuses there. All right, we will learn more about that structure in year 12, but you should recognize that oxalic acid is a diprotic acid. And then we have phosphoric acid, which is H3PO4. Okay, all right, let's have a look. What's next? Some questions will provide information about the acid without naming it, referring to it as diprotic or triprotic. Okay, you can consider these substances like, because they don't name it, H2X or H3X for diprotic or triprotic, and you can use the information to determine the stoichiometric ratio between the acid and the other substances. Okay, so if you're having a reaction with something like sodium hydroxide, 1 mole of a diprotic acid will react with 2 moles of hydroxide ions. Okay, so something like this, H2X plus NaOH will go to Na2X because you should recognize that if there's 2 hydrogens on there, each of them is a positive, then it's just going to form X2 minus, which is why you're going to need 2 of the NAs to form with that X, right, and form 2 waters. Okay, so the idea is that a diprotic acid will react with 2 moles of hydroxide ions. Okay, but remember that this has 1 hydroxide per molecule. If you were to react H2X with, say, something like barium hydroxide, it would just be BaX plus H2O, right, and 2 of them there, and you would notice that there is a 1-to-1 ratio compared to a 1-to-2 ratio there. Okay, so those are the ideas there with the with the stoichiometric ratios between different things, and you can also have triprotic acids will react in a 1:3 ratio. Okay, so just be aware that you can use those to help you work out the stoichiometric ratio between the acid and the other substance. All right, that's it. Adios.